Hi everybody, this is Thiagarajan. Welcome to this website VTRENWGSoft.com. So in this video I would like to explain about the software application available for the earthwork calculation for embankment. In the previous video I had explained about the earthwork calculation application for a plain ground. If we want to make up a low-lying place of a large area to make it a level ground, so how the earthwork calculation, can be made, quantity can be arrived at, how it was useful, I had been telling. So this application also, it is similar to that, but it is having some additional features. That is, you all know, as far as embankment is concerned, it is in trapezoidal shape, and we have the ground level, formation level, and side slopes. And take care of all those the features and parameters, and we have to calculate earthwork quantity required. And if you see your this is your formation shape normally. This is our ground level. This is our formation. We have top width and side slopes, both side, right hand side, left hand side. And suppose you want to construct a new formation, you want to form a formation newly. So this is our alignment of the road or embankment. So normally, for calculation, we need the data, input data. That is input data, means that is for the existing RLs. First existing RLs, you must have the data. And what should be the final RL that you should have. So with these data and using this application, you can compute the earthwork quantity required. Here, what you should do is first you go to collect your existing RLs, taking your 5 levels, taking cross-sectional levels at every point. For example, this is your alignment. This is your alignment. Chain is 0. You have to take some initial levels in the cross section, and 10th meter, and 20 meter, and 30 meters, so on. You are taking. The distance is according to your requirement, maybe 10 meter or 20 meter, or maybe this is according to the accuracy you want. You have to decide. Closer distance, more will be the accuracy. And so, like that, where you have to take the mean levels first. So, for example, this is your ground level. This is your center of the alignment, C, and we have to take levels left hand side, right hand side. This how much distance you should cover, that you must know, because you can it's according to your height of the formation. So normally we need the data existing RLs for the bottom of the formation. That means this bottom of the formation, the bottom of the formation will be according to the height of the formation. More the height, more will be the formation width. So here we apply here we have some cross side slopes. That maybe you can have some 2:1 or 1.5:1 or 3:1 according to your slope stability. You have to decide. With this, we'll have some idea. So what will be your bottom of the formation to the extent you have to go. You can go even beyond that also for some for safer side, for can keep some data. So here, where we have to take levels, initial level, that is at center of the alignment. And here one more data you need at the formation edge. So for example, the width of the formation is 8 meter. This is 0. The 4th meter you have to take left hand side, and right hand side also for 4th meter. And the slopes also you have to take some interval, some 1 point or 1 meter every 1 meter. That means here this is 0, this is 4 meter, this is 5 meter, 6 meter, 7 meter, like that you can go. Or 4 meter, 1.5 increment, you can go 1.5 meter also. Like said, left hand side, right hand side, you have to collect the existing ground level data. So those data normally, and we are keeping readily in a Excel format for importing into the application. As far as final proposed level is concerned, what you should do here, this is the center of the alignment. You have to fix your final level, what should be. So that you have to decide at every point and what is your final level center of the alignment. And like that here also both edges you must have. Suppose if you want to have the level formation, this very level, then 0, same, you have the same levels will have 0 and L1 and R1, and all 3 points will have the R will be the, proposed reduced level will be the same. And in case you want to give some cross slopes here, 1 in 30 or 1 in 40, whatever maybe, for the purpose of drainage, and you got to calculate. Suppose you are fixing some 100 meter at center under reduced level, and work out the reduced level at both edges. About 4 meter means you have to gradient. You have to work out the level. It will just slightly, it will come down. This is 100 meter means applying your 1 in 30 gradient slope, you will have some 19 point something. So like that, you have to arrive at the reduced level of the points at these three locations, that is center and L1 and R1. See, other locations and all, as far as proposal is concerned, need not worry, the application will take care. Fixing your 3 point, that is sufficient, entry is sufficient. Other thing you can leave blank, it will automatically application will calculate. So this is about your formation making in case of new construction, and in case of the existing formation. Suppose this is the existing formation, it is in the eroded shape, you want to make it to the standard profile. So in that case also here also same 0 and edge of the formation you have to work out. Only the 3, as well as proposed level is concerned, 3 point is sufficient. But as well as existing point levels, you have to find out center and edge of the formation, and this side up to the end of the bottom of the formation you got to go. Even some distance you can go beyond that also. Coming to the, in case of railway embankment, railway bank, we want to make up the formation. So normally the middle portion we will not touch. The middle portion will be there. That's different. But if you want to make up, this called cess. Normally railways is called cess. It is side slopes. We want to make up the cess and the side slope. We can independently calculate instead of okay. We need not combine both. Left hand side you can separately take levels. You can compute therefore, and right hand side you can separately. Taking levels you can compute therefore. Left hand side, if you are taking what you have to do here, you can keep this bottom of the ballast formation profile, keep it at 0. Then here, suppose this S width, for example, it may be 1.2, 1.5 meter according to standard. So we must have this S width of this much, 1.5 meter means 0 meter and 1.8 meter. What is the level? And here, according to the requirement, you can either this is 0, 1 meter, 1.5 meter, you can add 2.2, 3.2, and so on like that. Or you can give 2 meter or 1.5 meter, you can increment. Like that, you can take one side, that is sufficient. You can go to right hand side separately and deal. Here, as I have been telling you, as far as proposed level is concerned, here it is sufficient to enter the levels of the 2 points, that is here and what should be here. Suppose you want to maintain this point is 19.5, same 19.5 you have to keep here. Only 2 data filling is sufficient as well as the proposed level is concerned, and existing RLs, whatever actually you are collecting, that you have to enter. So this is about the 3 types of this one situations we have. So how the data is to be collected, and you have some idea. So now we can go straight away to our application. How we can use the application? You can see here. So this is our BTR engineering software. We can go here. Uh, so here we can choose earthwork embankment. So it is asking automatically. It is there BTR. You put the same. I have given a username password here freely. You can use this username and password and go into the application. This will be our page embankment earthwork calculation. So you have to import data. The data, as I have told you that you must have the data in Excel file. That is, we must have the two Excel file. One Excel file is for the existing oral, other one for the proposed oral. So before importing, let me explain about the Excel format, how it should be. Here, for your convenience, I have given here four buttons are there. The first two button ERL data B and FRL data B, it is for the bank. Complete bank. This ERL data C and FRL data C is only for the cess erosion. Suppose one side, if you want to deal only one side, right hand side or right left hand separately, you want to calculate the earthwork required for the eroded cess to make up. So this format I given. This is for the complete embankment. For the ground, if you want to make a new formation or complete formation is eroded shape, you want to make it a whole. So this two data available that you can make use of it. Here, let us. This is sample data available. Let me first download. I will show you how it can be downloaded, and you can see the format. And similar to that, you can enter your data and import into the application. So first, let me that is the URL data B back existing URL. Just opening it. Hello. So like that, the FRL data, the okay. See here, this is our ERL data as far as full formation is concerned. See, we have the same pattern what we have discussed in the previous video for the calculation of the plane ground. Same way, this is one first column is ID, second column chainage and distance and URL and C. Is here one is different. Difference is there. CLR, that is center left right. I put like that. CLR. That is chainage. You can put some serial number. ID. Chainage. First cross section. For example, zero chainage. Here I have taken some 64 60 meter chainage. You can have zero chainage like that. Then the first chainage, that is how much data you can. This is first chainage. This is first chainage. So this is center, zero. This is center. This is left and right. So your data should be entered in this format, this way. That is 0 meter. This is levels, and 2.5 meter left hand side. This is our levels, and 3.5 this level, 4.5, 8, and 10 meter. 0 to 10 meter. These are all our existing levels. Like that. 0 to 10 meter, right hand side also. 0 is constant, maybe same. And right hand side, 2.5 meter, what is your levels? 3.5, what is your levels? 4.5. Like that, you take them, you are recording you are entering keeping your existing oral for the first chainage, like this. And similarly, for the next chainage also should be like this. And till to the end of computation you require, you can have the data similar way, like that. We go up to the chainage of this here. I'm going to 690. That means 6940. That is end. Here 6460 to 6940. Every I mean 20 meter I have taken here. I mean every 20 meter I have taken here. So this should be our format. This is your existing orals as well as bank is concerned, and as well as your some FRL data. Now we are coming to the final oral data. This is your bank. Again opening using it. This you can save it somewhere. You can save it somewhere. See here also same whatever the column you had, same column, but here some difference is this distance DRL. Earlier we have some ERL and CLR. Here designed level RL level and actual final R. The two levels I am just adding it. Here Y means design level means some what should be our final level. Suppose we want to know only after existing our actual level. For that you want to compute the quantity. This column is required. That is why I have given here the designed order and actual final order. The two columns is there. This is CLR, center, left, right. You have to enter the center location or left hand side location or right hand side points. So whatever the distance you have taken in the existing oral, the same distance you should have here. Here each chainage, same whatever. Simply copy the existing oral, here, and you can change this one. Instead of ERL, you put the DRL and AFRL. Instead of one column, you include them inside the two columns. You give the heading of DRL and AFRL, but this and all should be the same. Then only it will work. Should not vary. Your point in the existing oral and your should not be like that. Okay. Here, what you have to do, as I had been telling, here it is sufficient to give the data of only the top of the formation. You don't worry about the slope. As far as here it is concerned, and 0 point and 2.5 meter and 3.5 meter, I think this is center of the point. These 2 points actually, this also taken 2.5 top, and here also 2.5 and 99.5 top of the formation only. So otherwise you can sufficient have only 3.0 and 3.5 sufficient. 0 and 2.5 sufficient. It is sufficient. Okay. So similarly, each chainage you must have. You must have your similarly you must have, okay, each chainage you must have the data. Again, I'm telling you only the top level. No, wherever you go, the top formation is level. So that data alone sufficient as far as proposed oral is concerned. Rest of thing you can not the slope locations may not enter your data. You can keep them free. It will be automatically taken care of by the application. So what next? Okay, this is about the final oral data, the format. This format you can download and save it. Even this format also you can the same file you can use it for doing some trial. See how the calculation is done. And if you want to actually do with your data the similar way, the same format, and you have to keep your data and you have to import it to the application. Okay, this is about the embankment. Let me save here. In case I have not saved here, I'll save somewhere in desktop somewhere. You can save it in somewhere. I'll put something like that. This is final oral. Like that These also are not saved. I will save it. You should rename it. Some name you have to rename it because same Earthwork be like that's coming. You put this is actually ERL. BERL, bank ERL. Okay. So we have two data here. Two data, that is B1. I have to no, this we can rename it otherwise. This is actually FRL. So formation data. We have two Excel file levels. One is for earthwork calculation. I mean, that is for exiting oral data. This is FRL data for bank. Okay, the two files are there. This is the I kept in this one desktop. Now you can import how it works. You can see. Before that, I want to say here by default the slope of the formation I kept as 2, left hand side as well as right hand side. Horizontal 2:1, vertical 1. 2 horizontal, vertical is 1. Both left hand side, right hand side, I keeping 2. This is default. If you want to change it, you can change it, but default is 2. So now you can go to the, you can just application, you can import the data. You are now importing. When you are importing, it just this box is opening. It just asking, go to browse the file location, and you have to click this button so the data will be retrieved. So you have to browse. First browse. I think it is in desktop. Some ERL something. No ERL. Get a lot of files here. Okay. Here. ERL B. ERL information B ERL. Okay. Now you can choose this one. Okay. You can choose this one. You can now browse. This is your file. Existing oral data file. And click this ERL button. First you have to browse, then you have to click the ERL button. So now your data has been returned. Come to the grid now. Okay, this is only the first chain is like that. It will have complete entire chainage. It is there. It is sufficient to click one time. First, but visible is only for first chainage only. So rest of the chainage data is available fully in the. Now it's completely important. Like that, you have to go to the final oral data also. Here find B final oral data. Open. Again here you have to click FRL. First you have to browse. Carefully you have to do it. It's FRL. You click FRL. FRL data. FRL button you have to click. Here you see only this portion alone you have the data. The rest of that thing it will work it out. Okay. So now we have the existing oral and you have the final oral. The two data you have in the table now. Next, what you should do, carefully you should just understand here. You should not, calculate button, it is now disabled and you cannot do it also. These buttons are available only for just to see the next chain. For example, if you want to next chainage, what is the data? It is just these buttons, next, previous, end, and all. But when we calculate is enabled, don't click now. First, okay. First, before calculation, you have to go to the slope. First, before calculation, you have to do application of the slope. You have to apply the slope first because we have set two horizontal and one vertical. The slope to be applied. Once applied, and some in our proposed level we have entered only the levels of the top of the formation, and rest of the location it has to be calculated considering the slope you entered. So you have to apply slope first. Mind it again, I'm telling you before calculation you have to apply the slope. You click slope, it is now processing, and here it will take some time because uh, more the data, more time will take time. And my humble request is as far as this application is concerned, it is done online. As far as the embankment is concerned, it is a lot of iterations is there, do a lot of calculation. That is why what I want to say is you have to restrict the length. We want to do calculation for some long stretch, you restrict to 1 kilometer. So first of all, every 1 kilometer you go, every 1 kilometer you calculate, then go to the next kilometer. Keeping 5 kilometers, 10 kilometers, no, it will be time consuming and some time to time out. So now I have applied slope. Some place it is just vacant. Don't worry about it. Don't see that. It will be okay. Now applied slope. So slope applied also is come. The label has come. Now next we can go to the calculation. Calculate. So this box is open now. There are options. What are the options? Design level with the cutting, design level with filling only, actual finish levels, and a minimum final level. There are four options are there. First option, design with the cutting and only filling. Suppose whenever you do some formation, existing formation, you want to make up the formation, there will be filling, some portion will be cutting also will be there. Because of the disturbance slope, somewhere it will be more than the required. So that will there will be cutting. So complete cutting and filling quantity you want to calculate the first option. Second option only filling. Cutting you forget, only you want to know the filling quantity. So this option. Third one actual finish levels. That means profile is perfect. No, we have the trapezoid profile perfect. That is designed levels. But sometime when you are after execution, this quantity may not be to the standard profile. Sometime there will be shortfall. Sometime there will be excess. Okay, but as far as this button, this option is concerned, actual. It did not calculate the quantity of the standard profile. It calculate the quantity of the actually executed quantity. Coming to the minimum file level, that again this is very important. Suppose this is required when it is required after the completion of the work, after earthwork is completed. Already we have taken the initial levels, and now final level after execution you are taking, and you want to decide payment. Payment some place some condition will be there. That means you cannot give any payment for the shortfall to the standard profile. And also, if the contractor does work excess more than the standard profile, so he is not eligible for the payment for the excess as well as shortfall. So taking care of both things, it will work out the quantity that is minimum final order. This is one option available. There are four options available. Using according to your requirement, you can use the option, and you can click OK. Now I'll just do a design of the cutting, some estimate purpose like that. Yes, now we got the result now. Now, see here you see the complete what is the actual FRL and DRL, FRL, everything has given. And quantity also here, but it is here minus, I mean more cutting is there, like that. So this is filling, this is your cutting. So cutting is more than your filling requirement. So this is your result you got. And if you want to print it off, you can see the print, you can print it out, you can export Excel, that is possible. Here you can drawing, you can do the drawing. This is a drawing, you can take drawing also for each section, clicking this button. So you can go to the print, if you want to see, you can go to the print now. So here, see each and every section, what is your this is existing or design level, actual, final or, and this section, what is the cutting area, what is the filling area, net filling area how much, and here net filling area how much, taking the average. Okay, here this thing, each section same way design. Each section it is working out the quantity area and average is this area into the distance will give you the quantity here. So here this and this into now it is only cutting involved, there is a minus is come like that. If you go to the next section also something, this and this averaging it into the distance will give you the this one. Here 0.123 and 0.46 averaging into distance. What is the distance here? 20 meter. Okay. Into 20 meter will give you the value. Average area into distance will give you the value. Like that every section it is calculated, taking the average area of the 2 points, consecutive points, and multiply by the inter distance will give you the volume of the particular section. So like that, this is worked out. Then if you can export to Excel also, you can see. Clicking this button, you can export. It will ask something, you give yes. This is your Excel data, same thing. You can take printout now. This is about the result. I just close it down. So go to the application now. So now this is, so like that you can get the drawing also. Get the drawing. You clicking the button drawing. So suppose first section you want the drawing. Choose something or one also you can choose, or show. Click show. Now we got the drawing. You got the drawing. Okay, this is our the existing oral. This is your final oral. Okay. Okay. This is your existing oral. This is your final oral. So like that you have the drawing also. So like that if you wanted to see the 1660 section, chain section, there is next means you can go to 60, 64, 80 also. So like that each section you will have the drawing, you can print out just like image. Right click it and you will have the save picture, something like that. So you can save. Okay, you will get the drawing printed out. So this is about the first. That is in case of embankment. Similar way, you can have new formation or eroded bank. You can just import your data into the application. You can calculate. We can get printout as well as printout of the complete data, I mean solution, as well as the drawing. It is possible. Let me close this drawing and print solution and all. So go to the home. Again, if you want to work out the same thing, it is for the sys. Only for want to make up the sys. The data will be like this. Let me import this data, sample data. So you see here, only 3 sections I put here. Okay, right. See here, this is first chain, second, third chain. This is the left hand side only I have taken. See, for example, here, here see only one side. Here only left hand side alone if you want to tackle, you want to deal the erosion of the says slope, you want to make it up, you want to calculate the quantity of the earthwork or quantity of the work executed after completion. How the data is to be, I mean, collected and imported. I will just show. This is here this case only bottom of formation. I mean ballast section. At this location, I am keeping it 0, and the width of the cess, the standard width you have to give cess width 1.2 meter or maybe at this distance you have to take level. And subsequently any distance 1 meter every 1 meter, that means here 0 1 means you have to add, should not give 1 meter, you should add 0 1.2 then plus 1 meter means 2.2 3.2 like that. So if you want to take only one side and you want to do like this. This Excel file, this is okay. In this case here 0 I'm center, then 1 meter, that says width actually here 1 meter is a 91.2 meter, and subsequently 2 meter and 5.5 meter 37.5 meter and so on. So levels I'm taking, but 3 sections I've taken. Similar way I'll just okay, anyway you can save somewhere, save this one, save as same way desktop. It's not B actually. This says some you can give says CRL. Okay, save it. Okay, close it. So like that you have to take the sample data of the final RL also, so that you can see the format accordingly. You can input, give your input of your data. Here 3 sections are taken, but see here I have given only the top levels of the formation, the 2 point, that is center, and the center means that is the 0, that is the bottom formation, bottom of the ballast section. There I am giving 0 meter, that is 99.5, the 1.5 the edge of the formation, this level and all, and we not enter, it will automatically calculate, the software will take care. Okay, so like the 3 sections I have put here. Similar way, similar format, you have to keep your data ready and you have to import to the application to get the quantity worked out. Okay, so this also I'm just saving it. Save as Okay, desktop I put. C. This is FRL. So this is your file name of the final or data I've saved in a desktop. Okay. So now you can work it out. So you have to go here, import. Same way you have to do what I explained it earlier. This is C ERL. Enter. Okay, enter. Only one side only is coming. See. Next, you have to go to the says FRL data. Browse it and clicking FRL button. Earlier we have to do ERL for this one. Now this is our FRL file, data file. After browsing, you have to click the FRL. So then after that, what to do? You should not go to the calculate. Before calculation, you have to go slope. You have to apply slope. Slope is, see that slope is applied. So now the slope is applied. Now it is the label as visible now. So now we have to go to the calculate. Same way I already explained. There are 4 options. Now we are doing only for the estimation. We can just click it and OK. Okay, now it's calculated now. Okay, it has come. This is your quantity. Volume earthwork is 56. That is filling is 75, cutting is 70. So 75 minus 90 is 56 is come. This is our total. Okay, this is our earthwork calculation is come. If you want to see the printout, same way click export it. And drawing also you can see here in this case. So drawing is concerned. So only one side is coming. Okay, now it is only one side. This is our bottom of the ballast section. This is width, this is slope, this is ground level. So this only blue is now that is called standard. This is your actual this thing. As well as 6 section 1650 chainage. So this 4 should be filled up. This should be it's coming in the cutting. So like that each section, and you can have the drawing also. Go to the next. Okay, like this. Next. Like that. Each section will have the drawing. You can take print out of it also. Just right click, save as a picture. It's only picture image. You can save it and you can print it out. So now, so this is the application for the earthwork calculation in case of embankment, and this application can be used for making up the new formation as well as to make up the existing formation to the required profile. I think it will be more useful for you. Thank you a lot, and next video I will say about the next application.